Hello friends, in this AV we are going to talk about the numericals of chapter 5, that is refraction through a lens. We would be solving some of the numericals of exercise 5C. So before we go into the numericals, we will look at some of the important points that we have to keep in mind while solving the numericals. So here are the points. I have already written it for you. First of all, the sign conventions. Now, for concave lens, all the values of u, v and f are negative. We have to keep this in mind. If the given lens is convex lens, then u is always negative, focal length is positive, v, that is the image distance, is positive for real image and it's negative for virtual image. The lens formula is 1 by v minus 1 by u is equal to 1 by f, and we substitute these values of v, u and f along with their respective signs that we have already talked previous to this formula. Now when we talk about magnification, magnification is given as length of the image divided by length of the object, that is v by u, of course again with the respective signs. M, that is magnification, if it is positive then the image is, sorry my mistake here, it's virtual image, and if the magnification is negative then it is a real image. Then we have the formula of power, that is 1 by focal length, and the unit of power is diopter. So with this, let's try to look at some of the numericals of exercise 5C. The first numerical says, at what position a candle of length 3 cm be placed in front of a convex lens so that its image of length 6 cm be obtained on a screen placed at a distance 30 cm behind the lens, and what is the focal length of the lens in part A. So here we have written the given things, that is the length of the object is 3 cm, length of the image of the object is 6 cm, image distance, that is v, is 30 cm, and the lens that is given to us is convex lens. So we know from the formula of magnification that m is equal to I by O, that is image length by object length, or is also equal to the object distance by image distance by object distance. So we make use of this. I by O is equal to V by U. So that is 6 by 3 is equal to 30 by U. Very simple calculation. So we get it as U, that is the object distance, is 15 centimeter. That means it should be placed at 15 centimeter. Now the second part of the question says we have to find the focal length. So for finding the focal length, we are going to take help of the lens formula, that is 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to 1 by image distance is 30 minus 1 by object distance we have calculated as 15, and since it's going to be in front of the lens, so we put minus sign, or you can check from the sign convention that we discussed before starting the numericals. So u is taken as negative. So when you calculate it, minus and minus becomes plus, you take LCM and solve it, so you get 3 upon 30. So when you divide or simplify, 3 ones are 3, 3 tens are 30. So this is 1 by f is equal to 1 by 10. So therefore f is equal to 10 centimeter. Now let's have a look at question number 2. It says, a concave lens forms the image of an object kept at a distance 20 centimeter in front of it, at a distance 10 centimeter on the side of the object. What is the nature of the image? Find the focal length of the lens. Just look at the sign convention and use the lens formula, and you will be able to solve this. This is very easy. So we move on to the next question, that is question number 3. Question number 3 says, the focal length of a convex lens is 25 centimeter. At what distance from the optical center of the lens an object be placed to obtain a virtual image of twice the size? Twice the size means twice the size of the object. So here you can have a look. We know that the magnification is given by V by U or V upon U. So we want the magnification to be plus 2, means twice the size of the object. So plus 2 is equal to V by U, which implies V is equal to twice of U. So we know the lens formula, that is 1 by F is equal to 1 by V minus 1 by U. So we substitute the respective values. 1 by 25 is equal to 1 by V is 2U. So 1 by 2U minus 1 by U. So when you solve it, it comes out to be U is equal to minus 25 divided by 2, that is 12.5 centimeter. The minus sign tells us that the object would be placed in front of the lens. Now let's take a look at question number 4. It says, where should an object be placed in front of a convex lens of focal length 0.12 meter to obtain a real image of size 3 times the size of the object on the screen? This is same as question number 3, but let's take a look. So we have written the given things. Focal length is 0.12 meter. Magnification is minus 3. Why minus? Because we have discussed in the sign convention that for real image, magnification is negative. So magnification, as we know, is equal to M is equal to V by U. So magnification is minus 3 is equal to V by U. So V is equal to minus 3U. As I told you, it's same like the previous question. So we are proceeding in the same manner. Now we know the lens formula, that is 1 by F is equal to 1 by V minus 1 by U. So we substitute the values. 1 by focal length is 0.12 is equal to 1 by V. So V is minus 3U minus 1 by U. So after we solve it, we simplify this portion, you take LCM and all those things. So you will get minus 4 upon 3U. So 3U is equal to 0.12 multiplied by 0.12 multiplied by 4, that is minus 0.48. So for finding the value of U, we just divide 0.48 upon 3, that is minus 0.16 meter. Now we'll take a look at question number 6. It says, a lens forms the image of an object placed at a distance 15 centimeter from it. So U is minus 15. At a distance 60 centimeter in front of it. So image distance is minus 60 because it is in front of the lens. We have to find the focal length, the magnification, and the nature of the image. So here we have written the given things, that is the object distance U is equal to minus 15 centimeter, image distance V is equal to minus 60 centimeter. We know the lens maker formula or lens formula, that is 1 by F is equal to 1 by V minus 1 by U. So we just substitute the values, that is 1 by F is equal to 1 by minus 60 minus 1 by minus 15. So when you simplify it and take LCM, LCM would be 60 minus 1 plus 4, so that is 3 upon 60, which is 1 upon 20. So 1 by F is equal to 1 upon 20. So F or the focal length would be 20 centimeter. Now the second part of the question asks us to find the magnification. We know that magnification is V upon U. So the value of V is 60 and the value of U is 15. We just put the values and divide. So magnification is 4 or plus 4. Now the nature of the image is virtual, erect and magnified because we are getting 4 times the magnification. Now let's take a look at question number 7. It says a lens forms the image of an object placed at a distance of 45 centimeter from it on a screen placed at a distance 90 centimeter on other side of it. Name the kind of lens. So lens is going to be convex only. Find the focal length of the lens and magnification of the image that will be produced. So here I have written it for you. As the image is formed on the other side of the lens, the image is real, hence the lens is convex lens. Now the second part, we have to find the focal length. So we know the lens formula, 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to 1 by v is 90 minus, because it's being formed on the other side, minus 1 by object distance, that is minus 45. So again minus and minus would be plus, you take LCM, then divide everything. LCM is 90, so 1 plus 2 will give you 3. 3 upon 90 is 1 upon 30. So 1 by f is equal to 1 upon 30. That means the focal length is 30 centimeter. Now the magnification is v upon u. So we put the values along with the respective sign. V is 90 upon minus 45. So magnification is minus 2. Whenever we say that magnification is minus 2, so m is negative, that means the image formed would be a real image. Now let's take a look at the next question, that is question number 8. It says an object is placed at a distance of 20 centimeter in front of a concave lens of focal length 20 centimeter. Find the position of image and the magnification of the image. Position of image and magnification of the image. So here for question number 8, we have written the given things. Object distance u is minus 20 centimeter because it is in front of the lens. Focal length is also minus 20 centimeter. If you remember, when we were talking about the important formulas in the beginning of this AV, I told you for concave lens, everything is gonna be negative, be it u, v or f. So here we write the formula. We know the lens formula, 1 by f is equal to 1 by v minus 1 upon u. So we have to find the value of 1 by v, that is position of the image. So 1 by v is equal to, we take minus 1 by u to the other side, so it becomes 1 by f plus 1 by u. Now we substitute the values along with the respective signs. So 1 by minus 20 plus 1 by minus 20. So when you simplify, 1 by v is equal to minus 1 upon 20. So minus 2 upon 20, which is equal to minus 1 by 10. So v is equal to minus 10 centimeter. That is, image is 10 centimeter in front of the lens. And finally the magnification part. Magnification m, here m is equal to v upon u. So we just substitute the value, minus 10 upon minus 20, that is 1 upon 2. So magnification is plus 0.5. That means magnification is positive. So we know that the image is going to be a virtual image. So we will stop here in this AV, and the remaining questions I will upload it by making another AV for it, so that the videos don't become too long. That's all we have in this AV for you. Happy learning. God bless you all.